Everyone. Sorry for the late start. I'm standing in for Pamela today, and I have with me Dr. Candy Hansen, who heads up JunoCam, and so we're gonna chat about that today. All right, Candy, do you want to introduce yourself real quick? Oh, hold on. It said that you are muted. Hold on. No, I think it's on my end. Just give me 1 second. Yep, that's... Okay. Say something real quick. Can y'all hear Candy now? Let's see. Okay, say something else. Oh my goodness, what is wrong? I am sorry, everyone. It wouldn't be Cosmic Quest if we didn't have audio issues. Mythtown says have to keep the track record intact. Broken Symmetry, I'm not sitting next to a vacuum cleaner. I am sitting next to a fan. I apologize for the noise. I don't have AC in my office, so I really need the fan on. So it's going to be a little noisy on my end. Please, while I figure out this audio issue. Live troubleshooting. Always a good time. Okay. Okay, could you say something really quick? Okay, there it is. Go, that should be working now. Maybe. Okay. All right, if you could say something again, Candy.
Something again?
Okay, can y'all hear her now? Waiting for the chat to confirm. So, yes, okay. We have audio now.
Okay, great.
I apologize so much, Candy. Could you introduce yourself again?
Yes. My name's Candy Hansen. I work for the Planetary Science Institute, and I'm a member of the Juno flight team. The Juno mission, the Juno spacecraft is in orbit around Jupiter. And like pretty much all science missions, it starts with scientists getting together with questions they want answered. And in this case, it was a group that were really interested in the interior of Jupiter, the magnetosphere, the deep atmosphere. And so they got together and put together a list of requirements. That means that this is a list of the measurements you want to take and a list of the instruments that you need to put on your spacecraft in order to answer the questions and come up with new scientific results. Well, it turns out when you put that list together and you put the payload together, there really was no need for a visible imager. But my boss, Scott Bolton, the principal investigator for the entire mission, said, we can't fly to Jupiter without a camera. And so at that point in time, early 2000s, when we were writing the proposal, quite a bit of money was required to be set aside for outreach. And so he decided that we would use that funding to get a camera, a visible camera, on board the spacecraft. It would be our outreach camera. And so then Scott came to me, and because he and I had worked together on Cassini quite a bit, and asked me about a camera, because he's a fields and particles expert. And I said, oh, I don't want to do this. I'm not a giant planet expert. I study the moons. And anyway, about a week later, he came to me again, literally with a drawing on a napkin, and said, do you think this camera will work? And I said, no. And I said, I know who can build a camera for this mission, which we already knew was going to be in an elliptical orbit around Jupiter and be a spinning spacecraft. It's not easy to build a camera for a spinning spacecraft, but I told him, I know who can build this for you. It's Malin Space Sciences. And so Scott said, okay, will you be in charge of getting that camera? At which point I said, sure. And I've always been happy that he kind of gave me a second chance to be a part of the mission, because it's really been a blast. So we have on board Juno a rather unique camera. Because we were the last ones added, we got the leftovers of the resources. So things that control your design, like mass and power and volume and funding, all those things were sort of the scraps. And the one thing that really drove the design was the volume constraint. We had to fit inside the fairing for launch. And so that meant that we could not have a big, long focal length because the camera would have been too long. So Scott and I looked at the constraints on the design and said, okay, what is the one thing that JunoCam can do that is unique? Because obviously we're not going to make lots of movies from a distance like Voyager or Cassini or had done. And so we said, okay, the really unique thing about Juno and what's unique for JunoCam is that we will be getting our first views of the poles of Jupiter. And so that's what led to our decision on the focal length. And then, of course, related to that is the field of view. And so we are flying a camera that has a 58-degree wide field of view so that we could capture the pole in one image and not have to move the spacecraft around at all, just the ground track. And so 58 degrees compared to every other spacecraft launched into space at that point, compared to 3. That was the widest that had been flown. So I'll pause there. So that's my introduction, is that because Scott wanted a camera, and I knew somebody who could build one that would meet his constraints. I got added as a co-investigator to the Juno project.
Awesome. This is just personally one of like my favorite projects, especially all the citizen science around it, which we'll get into in a second.
Yeah.
Because I know like a lot of our viewers know that I love things that like merge STEM and the arts, and just like show like just how many awesome things we can do when we like combine science and the arts. And I am actually going to switch over to
Yeah. Well, in fact, that was our reason for being on the spacecraft, was to do community science. And it turns out that our camera can actually do real science and get publishable results. We've published at least a half a dozen papers in scientific journals. But the whole purpose of having this camera on the payload was for outreach. And so once we had the design and we knew what the pictures might look like, then we sat down. One of the gals that works at Malin Space Sciences is a colleague of mine from many Mars missions. And so she and I sat down and said, what needs to be done in order to operate a camera? And how will we have the public do that? And so we came up with 5 different approaches. Are you showing the mission? Okay, because we were very deliberate in what we set up. And so I want you to, if you don't mind, show the mission Juno page that introduces JunoCam. So it's got the 5 different categories of portals for our scientists. Yeah, I lost my link to the YouTube. No, I want well, we could switch to my PowerPoint if you would like, if it's easier. Okay. And the reason to do this is because this is sort of key to our whole outreach philosophy. And okay, so I'm going to share. So what you will see in a minute is basically the whole design of our outreach in a nutshell on a page. So my colleague from MS Cubed and I talked through what is it that an imaging team would be doing at each stage of the process. And there's 5 things. First of all, you start out with planning. What do we want to take pictures of? Why do we want to take pictures of this or that location? And the challenging thing about Jupiter is it's not like Mars. Everything is in motion all the time, and it's changing all the time because it's basically an atmosphere in motion. And so we thought, well, we have to know what the state of the atmosphere is before we plan our picture taking. And so that's that first box called planning. And for that, we enlist the amateur astronomers around the world. Discussion is where you basically argue about what's most important. And on an imaging team, that's generally done in a conference room behind closed doors, but we opted to put it out in the public. Voting means making decisions. Okay, we've had enough talk now. We have to make a decision. And then we can send commands to the camera to do what we want it to do. On the other side, once we take those images and they get transmitted back to Earth, they need to be processed. So we have an image processing portal, and I'll spend a lot of time, I think, talking about that. And then we save our results in what we call the think tank. And you can be involved in the actual analysis of the data by becoming a member of the think tank. So, so
To you and the PowerPoint presentation.
okay, so everybody heard me talk through this, and now you can see the 5 different portals. So let's go to planning first of all. This is where we enlist the amateur astronomers from around the world. Basically, we ask people, please send us a picture of Jupiter that you've taken with your telescope and post it on our, you can upload your pictures from your telescope, post it on our website. There's a certain amount of information we need in order to work with your pictures. So we have a little template for people to fill out. And these guys have all been wonderful, and they have the most amazing telescopes in their backyards. And so this has worked quite well. What we do with those images from our amateur astronomers is assemble them into a cylindrical map. So now we've got a view of Jupiter as it appears at that moment. And of course, all of those clouds are in motion, but that gives us a snapshot in time that we can use to plan our commands. And we also get quite a bit of help from the British Astronomical Association, the Jupiter division, They also assemble maps from ground-based data from more of the astronomers, so it's really the missing pieces get filled in, and quite often they label things, and that's helpful. So, for example, they
I'm
have
sorry. I'm sorry to interrupt really quick. Broken Symmetry says that looks like 4 delicious Jupiter burgers.
Anyway, I'm just trying to describe the community outreach, and then we can go on to beautiful pictures. I'm going to skip over discussion, voting, because they haven't worked out as well as we had imagined, and bring you to processing. So on the processing page of our website, we have 3 different galleries. The one at the top are all of the most recent images from the camera. And it says most recent, but you can click all the way down to the beginning of the project and see what actually came in 2017 or whenever. Then the bottom gallery is all the stuff that people send us. And we absolutely love this, because this is where the art shows up. This is where the science shows up. This is where I have this crazy idea show up. And it's all submitted by the public. I do look at everything before I approve it, just to make sure there's nothing disgusting or whatever. Never have had a problem with that. People have put the most amazing art, along with scientifically processed images and really creative renditions that are just limited by their own imaginations. So I go through and I pick out my favorites, and those are the featured submissions. So they're a little bit biased.
I think I remember there was it someone made a quilt?
Yes. We've gotten quilt designs. We've gotten oil paintings. We've gotten all kinds of amazing artwork. So if you'll forgive me for a minute for doing this, I'm going to take us to this picture.
So many pretty pictures.
So this is a nice illustration, I think, of the transition from science to art. So the first image on the left is what we post, and we deliberately do not process our images very much, because we want to leave plenty of room for our community to use their creative juices. And so the one on the left is the one that's typically posted under JunoCam, in the JunoCam gallery. The next one over is from one of our super users, and he has essentially become a part of our team. He has software that he processes the data to remove things like what we call a phase function, which is just the difference in brightness from the shadow, the terminator, to the illuminated limb. And so he flattens that out. That makes it easier for the next step of processing. He does some color reconstruction and color contrast, all very useful, and especially for doing science. Now, if you want to get into art, you go to the next over image by Sean Doran, and you can see how his choice of color palette makes it look really beautiful. And then the far right example is actually an oil painting.
Oh, wow.
So that's the transition. And I'll go on and I guess show a couple of examples.
Have you seen any of the oil paintings in person?
No, only what's uploaded on our website.
Because I don't know how many of our viewers know this, but like oil paintings have texture and have like an actual physical depth. So I'm just imagining what that must look like to
Oh
actually
yeah,
like see up close in person.
yeah,
Because
it's pretty cool.
it makes me think of like when I got to see Van Gogh's Starry Night in person, and you can actually like look down into the layers of paint, and it's just really cool.
Well, speaking of Van Gogh, his stuff has been the motivation for a lot of interesting takes. This one, um, you can see Jupiter in the night sky, and the same thing. There's the great red spot in the night sky, plus some of the white ovals. More Jupiter in the night sky. So people really are inspired by Van Gogh and our images and combining the two. These are some of my favorites because these are what we call circumpolar cyclones. And these were discovered actually by JunoCam because it's really hard to see the poles from the Earth. Jupiter does not have much of a season. It's only got a 3-degree tilt. And so these are just different renditions. All of them beautiful. All of them enhanced color or artificial color.
I love the movement.
Mm-hmm. This is another one that's more sort of, let's take a picture and make it more like almost cartoonish, more graphic, I guess is the better term. And I'll stop sharing after this. This is one of my absolute favorites. This is from Rita Najm, and she titled it Roses on Jupiter. And I just love this one. I love the composition and the colors and everything. So, Ally, I'm going to relinquish this back to you and stop sharing.
I mean, I think we could all like look at pretty pictures of Jupiter all day. Let me switch back over to just the two of us. There we go. Okay. Broken Simmons Tree says those are gorgeous. And then also, so they're discussing famous dolphin cloud swimming on Jupiter.
Oh,
I don't know if I know about this.
Yes, maybe I should take the share again.
Okay.
Can you? Oh, no, I can do it here.
Yep.
Yes, I know exactly which one that is. I have it in my PowerPoint. But first I have to find it. It's right here.
Going back to the PowerPoint.
So.
Oh, that's so cool.
So this is Jupiter's atmosphere. And it was just this one time. We didn't really see this little dolphin guy again. He was swimming along at 49 south latitude. We've had discussions over what's chasing the little guy. If that's a dragon or a monster or whatever hot on his tail. But that was one that, the public pretty much loved immediately. And here's one of our fun artist conceptions. It's okay. It's okay.
I love that.
Sorry.
Candy has 2 German Shepherds, so I know most of y'all are used to Pamela's Australian Shepherds causing a ruckus. So.
Anyway, this is Frank Olava, or maybe it's Olaya, imagines sitting on a starship going by Jupiter and taking a picture out the porthole, capturing the dolphin on his cell phone.
I love that. So it's actually my first time seeing the dolphin cloud.
Yeah. So yeah, that's one of our favorites. I have so many favorites, I can't hardly choose.
I know they're all just like so gorgeous.
Okay, so I will stop sharing again.
And now
Yeah.
is JunoCam still going?
Well, yes and no. We're in a very high radiation belt right now. We're going, well, actually, that was one of the slides I wanted to show.
Going back to, we can just stay in share mode.
Okay. Well, that's all the art I had in this particular.
Okay.
So this is the orbit. And so we started out coming in over the North Pole, leaving over the South Pole. And then it goes way out here to apogee, and then we come back in again. And so during all of this time, we were avoiding the radiation zones. Mm-hmm. Well, the orbit has evolved. Every time we fly by Jupiter, it moves the apogee more southward and perigee more northward. And so that's how we were able to get pictures of Ganymede and Europa and Io. We'll never get any more because the orbit has continued to move. And now, where it's moved to, puts us in this radiation zone. And we caught a big dose on perigee 73. Mm-hmm. And so we have not had any more images since perigee 73. That is, we've had more images, but they've been noisy and saturated. So what we've been doing for the last 2 months is trying to fix things. What we're doing is heating the camera and trying to see if that'll make the noise go away. So we're in that process of trying things. Mm-hmm. And so far we have not succeeded, but we still have our fingers crossed. So hopefully we'll recover.
I know a lot of these missions have a tendency to surprise you.
Yeah, here, maybe this is a better view. You can see how the orbit has been evolving. This is where we went into orbit. And you can see we're really far from the equatorial plane, so we're really far from the satellites. But as the orbit has evolved, it's brought us closer. And so as long as I'm still sharing, I'm going to go ahead and show you our Ganymede images. We were very pleased about being able to get these. And it was only because, the orbit was evolving.
Wow.
So we were able to get some scientific results, particular on Tros crater and on this dome that just happens to be at the subjovian point. Don't know what it is or why it's there, but we got some good images of it.
Wow.
And then we discovered 10 new Patera that had not been recognized before. That's like something that looks like a volcanic flow, except it's ice. So those were pretty cool results. On our 45th perigee, we flew close to Europa and got some fun stuff at Europa, and there were places where there just wasn't really where we were missing Galileo data. So Galileo, the spacecraft, actually did a good job of mapping Ganymede, but there were I'm sorry, Europa, but there were a couple of places where we could really fill in some blanks, and so that's what we focused on, and looking for things like chaos terrain and chaos terrain boundaries. And
what is chaos terrain?
it's kind of a jumbled up mess. It's not smooth like a patera. It's like this, where there's a lot of, it's not big relief. It's like, on the tens of meters scale, but it's not smooth, basically. And then we got to Io, and because of the way we had gotten into almost kind of a resonance with Io, we got a lot of flybys, and you can see them listed here. And then each one brought us closer up until PJ 55 and 57. And then after that, after 58, we started moving away again. So that's what's shown here. This is what our typical images look like. And then this is our best PJ 57 image, where we were at a distance of about 1,500 kilometers. And Io, as you guys probably all know, is volcanic. And so its surface is changing all the time because it's volcanoes erupt, flows flow, there's rifting, there's mountain building. And so really each image it's not completely new, but there are new features, new volcanic features to study. And so here's the best PJ 58 on the other side. And what we discovered was that we had so much signal, we could actually take pictures of Io in the night. So when it was,
oh wow,
when this is the dark side of Io, so we got some really nice images there as well.
I've got a couple of questions in chat.
Yes.
Broken Symmetry asked, would we see some of the blue colors in Jupiter's poles if we were actually there?
It is kind of tinted bluish. I would say it's a lot more subtle than what you see in our processed images because people like to stretch the blue. But it is sort of a bluish tint. And there are some studies about the nature of the aerosols in the polar atmosphere that are different than the rest of Jupiter, that could give it that kind of bluish hue.
Cool. And Q23, I think I'm reading that Roman numeral correctly, asks, are you releasing the noisy images too? That could lead to some other interesting art.
No, well, yes and no. We're not putting them out on our public portal because they're just too sad. And but what we are doing is we are archiving them in the PDS, and so they will be available to the public eventually. We just didn't, our whole thing is to process these images and have fun making cool products, and a big black picture doesn't really convey much. Even the streaky ones, we have posted some of the streaky ones, and so you can find those if you're really interested in understanding noisy images as opposed to no image.
And Skywatcher Jim asks, how longer do we expect Juno to last? Are the other instruments holding up well against the increased radiation?
Yeah, I mean, the spacecraft has lasted amazingly well, even in spite of all this radiation that we're going through. And the other instruments have had minor issues here and there, not as bad as what we're experiencing. Um, oh, but that is one of the things. Uh, the science instruments have their electronics inside what we call a vault, so they have extra protection from the radiation environment. Since we were kind of an add-on, our electronics are not in the vault, they're beside the vault.
Oh,
So they get protection on one side, but not the other. And so we are more susceptible to the environment.
back to the questions about the pretty blue colors. Broken Symmetries had a follow-up question asking about lower atmosphere blues.
No, those would probably be somebody's artificial coloring, or color enhancement or something like that. We don't really see much bluish at the lower latitudes. But we don't try to define what people do with the images. We don't say, you really should use yellows and oranges because Jupiter is sort of yellow and orange. And we just say, do something fun. Make this an enjoyable experience. And if you don't mind, share your products with us because we enjoy them too.
Love that.
I'll be honest. When we started out, we thought we would have a special gallery for art, but it's so hard to distinguish where the onset is. In some ways, it's all art, and in some ways, it's all science. You can't really differentiate one from the other because when you exaggerate color, you also make it easier to see detail because our human eyes really like that. So that makes it, useful scientifically. And I'll be honest, these are things I have learned, not the picture I came into, not what I was imagining for our pictures, for our camera.
Has it kind of like changed how you view the relationship between science and art?
Oh, definitely. Absolutely. Mm-hmm.
Broken Symmetry says, go STEAM team.
That's nice. I like that.
Yeah, just I get very excited about this project because like my education background is in literature and like fine arts, and so I kind of came to like science on the communication side of it, and it's just I don't know, it's neat to see projects where those two disciplines come together. I'm losing my voice. I'm sorry. It's just because I think like there's so much push to like separate STEM and the arts, and so it makes me happy to like meet scientists who are, working to like bring the two together.
Yeah. Well, I am a convert. The art convinced me.
That's really awesome to hear. Okay, we have a few minutes left. Does anyone else have any questions? And Candy, is there anything else you would like to share?
No, I think you've seen the highlights. Maybe I'll just move to this one.
Okay, we've got a question. Another one from Broken Symmetry. What would you give as advice to future probe creators for planet moon exploration?
Think about this. You know, it's easy enough to add a little camera like this on board. It's easy enough to set up a website where you publish your images and invite the public to be a part of it. It's been a wonderful experience. And part of it is because the public has reciprocated. When we set out to do this, I really wasn't sure how well it was going to go over. And everybody was just like jumping on board and enjoying themselves. And it's very, very heartwarming.
And, also, I have a question that might be a little bit of an obvious. Like, what is a circumpolar cyclone?
Oh, yeah. So we all know cyclones, right? Mm-hmm. There happen to be cyclones that are surrounding the North Pole and surrounding the South Pole, hence the name circumpolar. At the North Pole, there's 8 of them, and they're arranged in kind of an octagon. They've been there ever since Juno got there, so they're a long-lived atmospheric feature. Oddly enough, at the South Pole, there's only 5 of them, and they're bigger. So the atmosphere has sorted itself into these atmospheric formations that are very, very stable and yet different from one pole to the other.
That's cool. Is there a particular reason the cyclones are larger at the South Pole?
I think just because there's fewer of them.
Okay.
The ones at the North Pole kind of jostle each other.
It's kind of competing for space, so to speak.
Mm-hmm. So to speak, yeah.
Broken Symmetry says, like those storms on Saturn, too.
Yeah. Saturn has some cool storms, too. Saturn does not have circumpolar cyclones, though.
It's really cool. I know I keep saying that. I'm sorry. It's just, I love all the pictures.
Well, everybody should go to the website that I've got on the screen there and just check it out. There's so many beautiful images that people have uploaded. I mean, thousands, literally. So you could, while away a half a day just clicking through them.
Veronica Cure asks, how deep are those clouds?
Oh, that's a good question. Well, these are at the top of the atmosphere, so deep relative to what, I guess you could ask. But their thickness is a couple thousand kilometers. Oh, and the dimension across one of these would be like from Canada to Texas.
Oh, wow. So they're...
Yeah, so they're really big. But Jupiter's really big, so...
Yeah. So, like, probably in relation to the total size of Jupiter, they're itty-bitty. Yes, Veronica, huge storms for a huge planet.
Yes.
Everything's bigger on Jupiter.
Yes.
And Broken Symmetry asks, do those clouds make some kind of rain?
Yeah, we actually think there's ammonia rain at the high levels of the atmosphere. And once you get into the deeper, warmer parts of the atmosphere, we suspect there's kind of a slushy rain from the mixture of water and ammonia.
Oh, cool. So it probably smells like Windex on Jupiter.
Yeah.
Veronica Kier says ammonia rain sounds like a heavy metal band.
a new kind of art. Put
Should be
music to
making like Jupiter-inspired music.
Actually, some of our contributors have done that.
Oh, cool.
Yeah.
I think it is almost 3 o'clock here on the East Coast. I don't know what time it is where you are at. I think you're in Tucson, right?
No, I'm actually in Utah,
Oh,
and,
okay.
and it's
Cool.
almost 1 p.m. I mean, my company that I work for is in Tucson.
Yeah, I think we're both at PSI.
Yeah.
Veronica asks if there's any links you can share. I think, Veronica, we will be posting those with the recording of this on our Patreon page next week, I think. Yes, next week, because that's when I'll be editing it.
But if you want to just jot down the URL here, you can, click around from there. Learn more about the rest of the project.
Yeah, I am floating an idea to Pamela to maybe do a little like JunoCam art contest during our hangout-a-thon in October. So everyone stay tuned for more details on that. And I think it is top of the hour now, so I think we can go ahead and start wrapping it up. Is there any parting words you have?
Just, go to our website, immerse yourself, have fun. Go look for the oil paintings and the JunoCam painted on wood or Jupiter rather, painted on wood, and the quilts and the music. Have fun. Go have fun.
Very cool. Thank you so much, Candy. Appreciate it. Thank you for your patience while I stumbled through everything.
Oh, you did fine. All's well that ends well, right?
Yes. And thank you, everyone, for joining us. Take care. I know normally we raid, but I don't know enough about Twitch to do that. So I'm just going to say good afternoon, good night, wherever you are. We will see you on Discord.